Here's a review for the test. This first test for Chapter 4 is a non-calculator test, and here are the things you need to be able to do. For 4.1, let's take a look at these three formulas. Remember, the first two are not given to you, so you need to know how to do them on your own. But it's fairly straightforward. Remember, A is like the starting value. R is going to be the rate at which you're growing at a constant percentage, or decreasing at a constant percentage. And then X is going to be the time period, whether it's in months, days, and hours. Remember to put your rate in decimal form. This compounding interest formula will be provided to you, and this has to do with interest, so it has to do with money. The key word to look for is compounding, and this N variable stands for the number of compoundings per year. So N equals 1 is annually, semi-annually would be 2, daily would be 365, weekly is 52, monthly is 12, what else is there? Quarterly is N equals 4. That's why you need to plug in for here. T is always in terms of years. R is the annual interest rate. It's in percentage, and you have to convert it to decimal form. Remember, P is the principal, it's the starting amount, and A is the final amount that you have. So given an equation, you need to determine whether it's exponential growth, exponential decay, or neither. So it's exponential something if you see a base as a number and you have a variable in the exponent. Given that you have a positive A value here, so no reflections, no negative sign, if B is greater than 1, then you have an exponential growth. So for example, if I have 2 to the x, you're multiplying by 2 each time period, so you have an exponential growth. If your B value is between 0 and 1, so if your base, for example, is like 1/2 to the x, that means you're multiplying by 1/2 each time, so that would be decaying, right? Because you're decreasing by 50% each time period. If you have an A value that's negative, for example, y equals negative 2 to the x, right? Because the A value is negative 1, right? If you have that, it's a reflection over the x-axis, so you're going to end up having a graph instead of exponential growth looking like this. Notice that this is decreasing, but it's not decreasing exponentially, so the answer would be neither if you see a negative out in front. 4.2, be able to find inverses given an equation, a graph, and a table. One method you can use is the shoe-on, shoe-off method, where you stand at X and see what order of operations are being done to it. So you multiply by 2 and add to 5. Now you undo that in reverse order, so you subtract 5 and divide by 2. Rewriting this, your final answer would be F inverse of X is equal to X. You subtract 5, and then you divide the entire quantity by 2. The other method is the algebraic method of swapping the x and y values. So instead of y equals 2x plus 5, you would have x equals 2y plus 5 and solve for the new y value. Subtract 5, divide by 2, and rewrite using the proper notation. Since we had f of x, you would have f inverse of x equals x minus 5 over 2. Given a graph, be able to identify the inverse of that graph. The inverse will be symmetrical over the line y equals x. To find the inverse given a table or a set of points, you just swap the x and y values. So instead of 1, 2, you have 2, 1. Instead of 3, 4, you have 4, 3. For 4.3, you need to rewrite in equivalent form. So given a log, you can rewrite this in exponential form by doing this, right? 3 squared is 9, so 3 to the power of 2 is 9. Rewriting the exponential form in logarithmic form would be log base 5 of 1/5 is negative 1. So log base 5 of 1/5 is negative 1. Remember, you can check your answer by going backwards. 5 to the negative 1 is 1/5. For section 4.3, also be able to evaluate. Remember, evaluate means to find the value. So here are some of the more difficult ones. Find log base 27 of 3. So you do 27 to the what power gives you 3, right? 27 to what power gives you 3. Okay. Well, we know that, I hope you can see that cube root of 27 is equal to 3, right? Because if you make a little factor tree, right? 3 multiplied by itself 3 times gives you 27. So we can rewrite this as 27 to the power of 1/3 is equal to 3. Therefore, our answer is 1/3. Number 2, log base 4 of 0.5. Anytime you see decimals, I recommend that you rewrite that in terms of fractions. So 4 to the what is 0.5. 4 to the what is 0.5. I'm going to rewrite 0.5 as 1/2. So notice that I had a 4, like a 4 over 1, and it became a 1 over 2. So I'm probably going to have a negative exponent there since it's flipped over. And note that square root of 4 would give you 2, right? So 4 to the 1/2 would give you 2, but we want that 2 over 1 to be flipped over, so instead of having positive 1/2, our answer will be negative 1/2. So 4 to the negative 1/2 is equal to 0.5. Go ahead and try these two problems here, log base 5 of 0 and log base 5 of negative 5. I hope you'll notice that there is no number that we can plug in to get out 0 or negative 5. So the correct answer is undefined. There is nothing. If you put not possible or no solution, I will accept those as well. Question, what were the two squirrels doing inside of a log? They were having an argument. Right, so the inside of a logarithm, right, base b is called an argument, and the argument must be positive for it to be defined. So anytime you see the argument as negative or 0, in other words, not positive, it's going to be undefined.